Okay, we're continuing with the book here, Prevent and Reverse Afib and CHF by me, Pete Rogers. We're on page 134. We're going to be talking about ion pumps and especially K-factor. K-factor is the ratio of dietary potassium to sodium. And you want to keep your K-factor around 10 or higher. At a minimum, it has to be 5 or higher or you're going to have problems. Okay, so here's how a plasma membrane works. The plasma membrane is basically runs on electricity. The electrical current is a net outward flow of positive charge in the form of sodium ions. At the sodium-potassium ATP pump, 2 potassium are brought in, so that's 2 coming in, but 3 are going out. So more charge is going out than coming in at the level of this pump. And that leads to a net outward pumping of sodium. There's a gradient of sodium. It's about a 10-to-1 gradient. 10 times as much sodium outside the cell as there is inside the cell. That creates, based on this chemical gradient and the desire of the ion to equilibrate its gradient, that sodium wants to come into the cell. Sodium also wants to come into the cell because inside the cell in the cytoplasm is negatively charged, negative 65 millivolts. And so that means if you were to bring sodium into the cell, it'll voluntarily want to rush into the cell. You can couple that movement to pumping something out. And that's how you pump calcium outside of the cell. So active cells, excitable cells, they really rely on this, what's called a NACA exchanger. Na for sodium, Ka for calcium exchanger. So it's often abbreviated NCX. This can pump out thousands of calcium ions per second. So that's how the cell does it. Neurons will use half to even 2/3 of their energy to run this pump here because this gradient is so important. Because they have to be able to manage their calcium. This is going to come up over and over again, so you want to understand these things in physiology. If you're interested in the concept of ion pumps, I recommend you check out my lecture, Membrane Ion Pumps with Metaphors. It's the greatest lecture ever in the history of the world on membrane ion pumps. And I made up metaphors for each of these ions with old paintings. You know, sodium is the angry poor, wants to bust into the town, okay? Potassium is dear old dad doing his job running these pumps, okay, making sure things work, paying the bills. Magnesium is the hero. It's not shown in this picture, but magnesium hangs on to those phosphates and makes sure that ATP runs correctly. Magnesium does a few other things that are also heroic of it. Calcium is like the bossy mama wife, okay? Comes home from work, she's tired, she's grouchy, she's not very reasonable. She just starts yelling at everybody. You're supposed to pick up the garbage. You were supposed to do the dishes. You were supposed to clean the garage. When calcium comes in, man, things start happening. Everything becomes active, okay? So a cell, when it needs to be active, that's good. But if calcium stays elevated inside the cytoplasm when it shouldn't be, for abnormal causes like toxins causing hyperactivation of the cell, then the cell becomes overactive and it's going to need to generate lots of energy to meet those activity requirements, demands, okay, metabolic rate. And if it doesn't have the energy to meet those demands, the cell can go in apoptosis and die. So that's called excitotoxicity, overstimulating a cell to death. Okay, also, for example, a vascular smooth muscle, if its calcium in the cytoplasm stays too high, it'll stay contracted and the artery will stay narrowed, vasoconstricted. So all these things are going to play a role. And the bottom line is, when you eat a diet high in sodium, you dissipate these gradients because you'll have more sodium accumulating inside the cell and you'll have less potassium inside the cell. When you dissipate this gradient, these pumps don't work as well. And then calcium stays relatively elevated in the cell will stay contracted, and other things will happen that you don't want happening. That's important to know because your whole body depends on this stuff. Okay, let's go to the next image here. Okay, this is just showing the relative concentrations, and I've talked about this before, that basically the extracellular space, like blood and ECM, extracellular matrix, it's the same as like seawater in a sense. Sodium is high like seawater, salt water. Calcium's high because the water rinses over stones, calcium carbonate, the limestone. Okay, so that's how it always is. And because the gradients are so high, these are in millimoles, these are in nanomoles, you're always going to need ATP to pump against the gradient, to pump calcium outside the cell into, it's about 10,000 times higher outside the cell than it is inside the cell in the cytoplasm. So you always need ATP. And because you always need ATP, that means you always need good mitochondrial function. And then you always need to run those pumps effectively, meaning you need magnesium, okay? You need potassium. Okay, now here's a big thing. This is something big. If you understand what's going on, you might, and you haven't seen this before, you're going to want to like hit your print screen button here. You know, the little print screen button. It's just above the insert button on your second little set of keyboard keys. Here's the point. Fruits have a very high K factor, meaning ratio of potassium to sodium. So all these things are good for blood pressure. Because think of potassium as vasodilation. Think of sodium as vasoconstriction. The K factor in fruits is like 100 to 450 times higher than it is in the ratio of potassium and sodium. It's like 450 times more potassium than sodium. That's extraordinary. That's good. Okay, all these fruits are really good. Okay, so the fruits are in blue. Then I'm going to show you the starches. The starches are in purple. And with starches, you're in the ballpark of 20 to about 100 is your ratio of potassium to sodium. So starches are very good. You're unlikely to ever have a problem with hypertension. Okay. You could also see that if you had kidney failure and you couldn't handle potassium effectively, you'd be better off eating the starches than eating fruits because the fruits are too high in potassium. Does that make sense? Okay. But you just get a sense of these numbers. Starches 20 to about 100, or even 20 to 60 especially. All right. Now we're going to look at veggies. Veggies are in the color green. And veggies tend to have a K factor of about 5 to 15. So it's still good. It's still real good. But just for perspective, meat like ground beef tends to have a K factor of about 4. So that's not that bad, but it's not good either. So you're going to be a little bit hypertensive from that. Okay, now all these other things. Soy burger is really bad, 1.6 K factor. Remember, anything below 10 is undesirable. You want it like 10 or higher. All right, Cheerio cereal, 1.2. Potato chips, 0.9, less than 1. That's terrible. Special K cereal, which pretends to be a health food cereal, but it's not, in my opinion, 0.06. So you see the pattern? Like I was talking about, there's your K factor ratios. Fruits, 100 to 500. Starches, 20 to 60, 20 to 50, 20 to 100. Let's just see, especially 20 to 50. Veggies, 5 to 20. Animal foods, about 4. Processed foods, less than 2, really bad. So, you know, the processed foods are always bad because, remember, the potassium is intracellular ion. So you take a processed food, you grind it up, rinse it with water and solvents. You rinse away all the potassium. And then you add back salt to make it taste good and for preservative. So it's going to be way high in sodium. And it's going to be very low in potassium. So it's a terrible food. It's going to predispose you to hypertension. It also makes the food taste good, all the salt. So it's hyperpalatable, so to speak. So you overeat it and you get fat. And you're hypertensive because you're vasoconstricted. You're hypertensive because it's usually has a lot of fat. It also usually has estrogenic chemicals that are going to predispose you to gain weight. So that's the scoop on the K factors. That's important to know, that concept of K factors. Okay, so we'll call it a day right there. Hope you found that helpful.